Hello everyone, this is Nick Losi and I'm an Industrial and Systems Engineering student at Liberty University. We'll be talking about outsourced manufacturing today and its applications in IBM OPL Cplex. So let's start with the description of the problem. So a manufacturer is selecting a set of suppliers for the components of its products. Suppliers offer different discount schedules. All units discount or incremental discount. Each supplier has a supply capacity on the total number of items. The model is to find the purchasing quantities for each of the item from the suppliers to meet the demand at a minimum cost. The costs include purchasing costs and setup costs. Each time a positive quantity of any item is ordered from a supplier, there's setup cost. So the reason why I chose this topic was because that outsourcing is it's relied on heavily by manufacturing and industry, and companies are able to gain a competitive advantage by using outsourcing and by decreasing their costs. As well, IBM research indicates that people who do in fact use outsourced manufacturing they lower their administrative expenses and increase overall income. So the project here that I've been working on is to increase the capabilities of the model of the IBM Cplex example. So the regular example that it gives has features of a mix of suppliers that offer various discounts, setup costs for ordering, and the capacity limits for each of the suppliers. Now, what I am attempting to do and hopeful to do is add an additional constraint where there is transportation costs, aka, in other words, shipping costs for different quantities ordered. So, for instance, if a supplier 1 ordered, or if you ordered from supplier 1 under $100, the shipping cost would be $25, and so on and so forth. Now, this could get really complex when you're trying to minimize the total cost, and these do in fact become something you have to worry about, which is why we turn to something like IBM Cplex. So now let's take a look at the current model. I know this looks really confusing, but it's not all that bad. So I think we're going to take a look at it actually in a Word doc here. Okay, so your variables, you have your suppliers, items, and amounts, and then you have your quantity, which these are your decision variables here that are going to be changing. Now these are part of your minimization equation here. So the goal in the initial example is to minimize the total variable costs as well as the total setup costs. So the total variable cost can be represented as the summation of the costs and ranges times the quantity that you order. So the quantity that you ordered from supplier 1, item 1, for instance, if that equaled 10, and then you went over to your costs and ranges, and then you would look at item 1 from supplier 1, and you would look at the cost, the discount cost under for ordering something under 10. So you have the total variable costs as well as the total setup costs. Setup costs occurs anytime a cost occurs. As well, you have several constraints here. So you have a capacity constraint. You cannot order over a certain number. You have a demand constraint. You must order up to a certain number. And then you have all units discounted suppliers. As well, you have incremental quantities to be discounted. So for instance, one supplier may say that all of your units could be discounted, and then another one would say between this number and this number we're only going to discount you this much, and as the number increases we'll increase the discount. So now these constraints here represent putting the quantities within the correct range, and as well for in there. Okay, so now what I'm attempting to do is add an additional factor to the minimization. So minimizing total variable costs, total setup costs, and as well the total shipping costs. Okay, so the total shipping cost would be represented similar to the total variable cost. The cost range in quantities multiplied by the shipping quantity. Okay. So then here we have the same constraints, and then the additional constraints here, I tried to represent it similar to how it fits it within ranges for the incremental discount quantity, quantity discount here. Okay, so now let's take a look over at IBM C++. Okay, here, so I will try to differentiate between what is the normal model and what I added here. Okay, so let's see the best way to do that. To show how you pull examples from IBM, you go to File, Import, Example, IBM Log OPL Examples. Now here, this is an integer programming example that I used, and outsourcing, as you can see here. So you would double click that and click Finish, and it would import that example. And it looks something like this, which gives you a model file and a data file. Model file, so this is the example, you can see, and it's very similar to how we represented the model. Okay, and then it just has our data. So we have 3 items, 3 suppliers. 2 of the suppliers are all units discounted, one of them is an incremental discount. So you have the number amount of this number here represents the number of ranges, the breaks in the quantities that we order. Okay, and then you have setup cost, which occurs every time you make an order. And then these represent the costs and ranges. So for example here, for supplier 1, item 1, range 1, supplier 2, and so on and so forth. Okay, so this is a saved example from my work here. Okay, so now we're going to go over to my example. So now when you run the model of your outsource, the outsource model, sorry for jumping around so much. When you run the model, the outsource, the answers that it will give you are represented down here in solution. Okay, so now let's take a look at the contribution that I made or attempted to make. So I know that I have to increase the decision variables. So the decision variables that I added here were the total quantity sum, and that gave me this down here. So I wanted to add up the total quantity from supplier 1, from supplier 2, and 3. And my goal here was to then place these quantity sums into the ranges of my shipping costs. So my shipping break costs are represented down here. So you would have a shipping cost, you'd have a shipping cost range for items ordered under 100, for items ordered under 150, 200, and 1000. So those are represented here. So shipping costs and ranges from 0 to 100, if you order that number from supplier 1, it would give you it would be a 17.5 represented in dollars, I guess, cost to your shipping costs. And then these are just fictitious locations to think about it. So the goal, like I said, was to represent the sum of the total quantity ordered, represent those as integers in the supply quantity amount, and then ideally this would be multiplied by this shipping costs and ranges. Now, the issue that I ran into while doing this problem was that exactly that. I had issues sorting these into the ranges of the supply quantity amounts. So to describe this best, made an Excel sheet. So this was the problem I faced, and unfortunately I was not able to complete my 2B model because of so much challenges running into it, but I know ideally the algorithm that needs to be accomplished. So the shipping costs here, like I said, from supplier 1, supplier 2, supplier 3, and you have your different ranges. Okay, so then moving forward, this would be an ideal solution that it gives you, but also you remember that the total quantity ordered, these would be represented as a decision variable. So these would be changing because of these costs here. So whatever the total quantity sum that ideally would give you, it would be represented as integers here within the ranges. So supplier 1 had 130 would fit into this range, 220 would fit into this range, 120 would fit into this range. And then your total shipping cost would be your supply quantity amount times your shipping cost, which would be a sum product of this integer range multiplied by the shipping costs. So in conclusion, the 2B model I was not able to complete that, unfortunately, but with much more trial in the future, I believe that I will be able to solve it, and I'm thankful that you watched this video, and maybe I'll have a link as soon as I do solve this problem, and I will